Hello and welcome to TidyX episode 44. TidyX is a screencast where we go through and explain how our code works. My name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
And I'm Patrick Ward, and you can find me on Twitter at OSPPatrick. And you can find the home of the screencast on Twitter at tidy_explained. Or you can email us at tidy.explained@gmail.com. We love getting emails and questions about things that you might like to see in
Mm-hmm.
future episodes.
Yeah, exactly. We love hearing from y'all, or leave a comment down below. I'm sure as we're going through this, we'll bring up some stuff that we ask for some feedback on.
Yeah.
So this week's TidyX is going to be talking once again about another Tidy Tuesday submission based on this data here, which is a transit cost project. So it looks like they pulled a bunch of data from like the late 1990s to current times, I guess, the Corona times, and they were looking at what does it cost to do this transit project just overall and then per kilometer, because the question here that they pose is, why does it cost 20 times more per kilometer in New York versus Seoul? I mean, both are giant cities, lots of infrastructure has to go into it, but why does it cost more in New York? So I thought that was an interesting question there, and definitely very interesting data. Lots of fun visits this week, but there was one that, as we were going through and looking at the various submissions, we're like, whoa, that is really cool. That's pretty clever. And as we've gotten more into it, we're like, there's another level here of like being really clever. So
Yeah, for sure.
so the submission that we chose this week was from Martin Devaux. He submitted this pseudo subway plot, to be
Yeah.
clear, subway map.
At initial glance,
Visualization.
it's a subway plot, but
Yeah,
then you dig deeper, and
it's
it,
just really clever too.
it's a plot of information with a background on it that
Yeah,
makes it look like a subway plot, even though it's not a subway plot. But it's fascinating because he's combining different countries and bits of information.
and it's just like there's lots of levels of information here. So I thought it was a lot of
Yeah.
fun to go and like just visually look at, right? So
Yeah.
I was like, oh, it's a subway plot, or it's a subway. How did
Right.
he get that information out of there? And then when you look more, you're like, oh no, like each station is a project.
Yep.
The vertical line is how much it cost. So like you can see New York, San Francisco. So that each line is actually a country,
Yeah.
or like the U Link in Seattle.
Yeah, that hasn't really caught on.
Not really. There is like the BART here. I don't know.
Yep.
That's
San Francisco, kind of Bay Area, is the BART.
Bay Area Rapid Transport.
Bay Area rep. That's right. Yeah.
But then you can see like Tokyo over here has had a bunch of stuff. But yeah, somehow the U.S. is the most expensive, and
I don't
we
know.
still, I mean, public transport. I can't
Well,
say like I went to Europe last in 2019.
yeah.
Public transport was figured out there.
It's
It
amazing.
was
Yeah. Well,
so.
I do in New York City. It is.
I mean, yeah, I guess in Seattle it doesn't
Or
feel like it is.
Boston, New York City, Philly. I, I've lived in New York City and I've lived in Boston, and those are. I mean, I never owned a car. I
Mm-hmm.
just Martin is a student at Columbia, so maybe he can sort out why it's so expensive
Yeah,
in New York City. I
you can
did
remind me.
watch last night this on National Geographic an entire show about the New York Mafia, and
Mm-hmm.
so maybe that has some reason why it's more expensive there.
Yeah,
There's
you
some
gotta
sort
pay
of
off.
racket
You gotta
being
pay off the
run.
folks.
Exactly,
Yeah.
exactly.
But yeah, so we reached out to Martin. We're like, hey, Martin, yeah, we think your viz is amazing. Would you allow us to go through and explain it? And he's like, yeah, sure, no problem.
Yeah,
So he's also got a blog post here with his explanation of his thought process,
yeah.
what he was doing as he was creating it. So we pulled out the code and we'll go through and explain it. But I definitely suggest taking a look at his blog, because you can get into his mindset and what he was thinking as he was going through that.
He does a good job of working through the iterations of building to what we just saw on Twitter
Yeah.
from scratch. So
Yeah.
and that's always kind of cool.
Mm-hmm. So what we're going to do now is go through Martin's code here and try to explain how we understand what he was doing in the thought process there. All right, so the first pieces there is, and I've tried to also copy the text that he had, some pieces of text that he had there. But the first step is loading a bunch of R packages for him to use. Tidy Tuesday R, whoop whoop. Tidyverse, GG Repel to help with labeling, grid, PNG, and scales. So grid and PNG can be used for image manipulation kind of, and grid is for kind of layout. PNGs for loading PNGs. Scales is to help with the labels for the GG plot. He loads the data using ttload and pulls out the transit cost data set from it. So we got that there. He also had a piece of code here. So we've had to modify things because there were file paths in there and we needed to make it work, live. So what we had to do here is we added this here, so that it works. But he's loading in a CSV of country codes. So the data set comes with country codes that are the 2-digit country codes. So CA for Canada, US for the USA, and whatnot. So we want to convert that into the more recognizable full country name. And so this can be done. He has a CSV country codes, which is simply the country code, 2-digit or 2 new numbers, letters, English, and then the full country name. And so we created our own version there, and we're going to read that in. So now we're going to merge that together to create an updated transit cost data set. Generally, I would suggest actually assigning that to a new data set so you don't accidentally rerun it and then keep on building up your data set when you don't realize it.
Yeah.
I don't know. I'm always one that does not. I figure I've got enough memory on my computer so I can overwrite stuff. Or I should overwrite, or shouldn't overwrite stuff. That English. Pat, you want to take us through this?
So the merge is pretty easy. We've done this a number of times here. He's going to take his transit cost data set. The first thing that we've got there is just a little bit of a mutate. So we're adding a new column called code, and he uses an if-else statement, which basically says whenever it's UK, go ahead and call it Great Britain. Otherwise, use whatever country code was in that original column. And then he's selecting minus country. So he's basically just wiping out that old column so it's no longer there. And then he's going to go ahead and he's going to do his left join. So remember, it's a left join. So he's going to want to keep everything in the left-handed data frame. In this case, it's the transit cost data frame. And he's left joining that to country code. So if there was no match for the country code in the transit cost data, it would just plop down NAs, but maintain whatever row that was in the transit cost data. And he's explicitly saying that he wants to join these on the column code. So by equals code is saying where he wants to join these. If you left it out, and there was columns that had the same name, R would automatically just join them together. If you wanted multiple columns to join on, you would just have to put a little C for, and then just drop in whatever columns. Super easy. There's left joins, there's inner joins, there's anti-joins, there's right joins. They're all very helpful to use.
Mm-hmm. And if you get those, you can. They're very similar to SQL joins.
Exactly.
They are.
Yes, they are. They actually are the SQL joins. Yeah.
So if you get those, you can kind of, or if you know SQL, same idea.
Same idea. Yeah. And then he's doing a bit of renaming. So just a little data cleanup here. He's changing changing the name column to country, lowercasing the code column, so dropping the C to a lowercase, and then whatever was in the column E, I can't recall what E was.
And Thomas wasn't even sure. I think he said ID, maybe.
Okay, so he changed it to ID, and then he's selecting. This looks like he's more just ordering things up. So he's basically saying, I want ID, country, code, city, and then everything else plopped on to the right of that data frame. And that gives us a nice new large transit cost data set. Whoops, to work with. There we go.
Here, I'll zoom in a little bit more.
Okay.
There we go. So now we've got ID, country, the 2-letter code, the city, what the project was, start year, end year. Yep. RR, we think that stands for whether it was a railroad or not. Length, blah, blah, blah. Awesome.
Yada, yada. Yep.
Yada, 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 yada.
So now we're into that.
And so now, based on his comment, just taking a quick look at what's he got now.
Yeah.
So takes transit costs. So the start year data is it's left as a character, and that's why. The reason why is if you look at transit costs, start year, there's some weird values in there.
Yeah.
So they've got, where is it? Here we go. 5 years. 5 years. That's not a.
It's almost like somebody recorded at times how long the project took. It was 5 years, right? Instead of the time.
Not start. So so rather than dealing with that, and you could just call an as numeric on this data set and it'll work. It'll convert all the proper dates into or all the proper years into a numeric value. The problem is not problem necessarily, but it'll give you a warning very nicely saying, hey, there were some values in here I didn't know what to do with, so I turned them into NA because I didn't want to guess. Essentially is what's going on. And so it's kind of a safety valve. And what he's doing here is he's doing an str extract with any numeric value. So what this is going to do is it's going to pull out, or it's going to basically convert all of these and preserve only the numeric values here. So this would become NA, essentially. This would become 5. But there's still character values. And so you call as numeric on that to convert it into a nice numeric value without having those warnings of, hey, I tried to convert 5 years into a numeric value, but because I had character values in there, I had no idea what to do with it, so I called it NA. This way you won't get that warning.
Yep.
And then filtered to keep start year greater than 1950, and that would be to then drop off these guys here. So, okay.
Yeah, I guess what it really comes down to is knowing your data.
Mm-hmm.
If you are very confident that turning this column straight up, just saying as numeric on this start year column, and I know I'm going to get a warning that says NAs by coercion.
You're like, I totally know why, and that's fine.
If you know your data well enough that's okay, that's fine. Otherwise, you do it like this, where he's like, oh, I take out the numbers, and now I also know that the data was told explicitly this is going to be transit data from 1950 on. Then the 4 and the 5 automatically, you're just going to drop them by doing a little filter there. So it really is more just comes down to like knowing what you're expecting to see there, I guess.
Yeah, exactly. All right, so now that we've gone through, converted the start year into a numeric value, removed all those random values we don't want to be keeping, and filter will also automatically remove NA value, or not automatically remove NA values. It only keeps the values that are actually true for this evaluation. And so those NA values that we've got in there are now gone as well. Yep. So now we're going to throw it into a ggplot where the x-axis is going to be start year, which is why we wanted it to be numeric, and the y-axis is going to be cost per kilometer of transit in millions.
Kilometers per million.
Yeah, wow. And then we're going to add a geom line, and we're going to group by country. That way, it'll only connect the points for each country. It won't just try to connect all of them together. And then we're going to add a geom point to add a little bit of context and make the plot a little bit nicer. And wow, that's dense. Lots of stuff going on here.
Except for those
there's a
few outliers. Well, I think that top one wasn't that New York City, if we remember his Twitter.
Yeah. So there's a couple of these like rural expensive ones over here.
Sheesh.
But then the rest of the world is a little bit more reasonable maybe in cost.
Yeah.
But yeah. So that was the first viz. I was like just trying to get like what do I have? Because the final visualization he ends up making is kind of at least based on the blog, was like he had this idea from the start. And so this was like giving you an idea of what he had. So then we're going to jump into creating the iteration 1 of the actual viz that he shows out.
Yeah.
And so once again, you take transit cost, but he wants to then look at simplifying it a little bit. So the first thing he does is does a mutate on country and does an FCT lump 10. So what that's going to do is it's going to allow you to keep basically the top 10 countries, and all the other countries are going to be lumped together.
Called other.
Yeah.
So it'll be each of the top 10 will have their UK, Great Britain, USA,
Tokyo,
Japan. Yeah, exactly. Yeah, the countries, and then everything else is going to be plopped into this other category.
Yeah. And this will be by the number of appearances. This is not based on anything else. You can do factor lumping based on another column. Here it's just based on number of appearances.
Like you could have done it by price per million. So it's possible that there's a country that had like one really incident of building. Yeah, one incident of building a really expensive transit, and they would be maintained. This is actually number of events, cases that the
number of projects.
Projects, yeah.
So that's now converting converting country into factors. Now we're going to be rounding the cost per kilometer in millions. And so this was one thing that, I'd heard of and I understood, but I never actually used it before. So using the round function here to round at the tens point. So normally when we're using round, you'll just call round and that rounds at the ones point, so it'll drop off any decimals essentially. If you do round comma or value comma 1, it'll round at the tenths. So like 1.12 would round to 1.1. Right? Yeah. Here, or like if you used round value comma 2, it rounds at the hundredths place. Yeah. Mm-hmm. If you're using negative values, it actually rounds on the left side of the decimal.
Yeah.
Right? So here he's rounding at the tenths place, just to make the numbers a little bit cleaner for plotting purposes.
So a 2005 becomes a 2000, and a 2006 becomes a 2010.
Yeah.
And this is, if in any of our old screencasts where we did like NBA data or NFL data, and we wanted to plot by decade, I think we usually had like a 2-step process where it was like find the floor, find the ceiling, round, pull everything to the floor or the ceiling based on where in the decade. This is like a super, I've never seen this, but it was like, oh, that's pretty cool.
Yeah. It's like, oh, that's smart.
Yeah.
So thank you, Martin, for showing us that. And then once again, for converting start year back to the actual raw numeric values, then he's going to do a filter to reduce the number of countries that he's representing here. So he's going to keep any country that is not other, which is any countries that were not in the top 10 of number of projects that happened, then dropping China, Taiwan, province of China, India, and Turkey, because he just wanted to reduce the number of countries that were shown. Because, as we saw with the actual plot itself, there's kind of a lot of stuff going on. And then we're also only going to keep cases where RR equals 0. I think that's the majority of them, because he just wants to have the general transit projects not. We think RR stands for railroad, so and if it's 1, that means it is a railroad, and we don't want to keep those. And then we're going to throw it into ggplot, where once again, or the x-axis is going to be start year again, and y-axis is going to be cost per kilometer in millions again. But this time, rather than using a line, he's using a geom step. And we've used geom step in the past. I think this was like one of our earlier episodes. But
didn't we use it with Alice in Alice's interview?
Yeah, we did that there too. Yeah,
she had like the win, not win probability, point differentials.
Yeah,
right, over time.
Score worm.
Yeah, the score worm is what she called it. That's right.
So what geom step does is it draws a straight line along the x-axis until it reaches the next point along the x-axis, then it goes vertically up or down, I guess, depending on where it is. And so it kind of creates a really cool geometric pattern.
Yeah.
Now adding geom point again to points. He's going to be scaling the x-axis, but not actually scaling. He's really just defining the breakpoints. So where along the x-axis, he wants there to be the margin or the ticks essentially.
Another way you could have done it was with like sequence looks like sequence 1985 to 2020 by
Yeah.
fives.
Yep.
Looks like he's got
See,
fives. Yeah.
1985. 2020 by equals 5.
So it's a from 1985 to would be the argument, and then by equals 5. Yeah. Same thing.
So rather than manually writing that out, but
yeah.
And then also doing a scale y. So he's scaling the y-axis log 10. So he's logging by log 10 the y-axis, because as we saw in the prior plot, there are a couple projects that are like insanely more expensive than the others, so the rest of them kind of get washed away.
Yeah,
you don't get to see those. And then he's going to use the scales package, unit format function, to format the y-axis to make it look nicer. So he's going to set the unit to be m for millions, so because before it's just a raw number, and then adding a big dot mark is saying, hey, at the like thousands and millions place, add a comma. Once again, making it look a little bit nicer.
Yeah.
So we'll take a gander at this, and hey, that's starting to look like what he had.
Yeah, it's starting to come together.
So it's starting to draw all those lines there. Here's the subway stations. There's the lines going. So it's starting to look more like a subway map. There you go. So now it's on to the next iteration. Pat, you want to take us through this one?
Yeah. So building on what he had before, he actually keeps those first, whatever that is, 5 or 6 lines the same. So that's just his sort of pre-cleaning process. You could have, if you're going to iterate, you could have thrown this into you could always throw this into like a transit cost plot df or something like that, or transit plot df, or, you could have called it exactly something, and then so that you just don't have to always run it. Either way, it doesn't matter. He uses the same stuff to get us started. We're into our ggplot. We have the same information on the x and y axis. We have the same geom step function, so all of that stuff is the same. Geom point is the same. He adds in this.
There's the color here, though.
Oh, sorry, that's right. He did do a country, a color by country, and if you remember the plot, there was a legend in the top left that explicitly told us which color each of the line and points were. So that is the addition there. The geom step is not going to be all black now. It's going to have specific colors by country, and throws in his geom point. He uses shape 21. Shape 21 is my absolute favorite geom point shape, because it is a circle that is hollowed out, and then you can specify what you want the color in the fill to be. So in this case, he's saying, give me shape 21, and I want it to be filled white, which means that the inner part of the circle is going to be white, and the outer part is going to be whatever color the line is, or the geom step or the geom line is going to be. So that's what he does there. And then he uses this geom text repel. So we've used geom text before. Geom text is just a way to get text labeled onto the plot. What he's using the repel for is, if we were to just call geom text, it would plop those country names right on top of the points. You could do a little bit of finagling with the V just and H just and kind of push them or nudge them along. But geom text repel actually finds an optimal point to put that text in, and then if it's further away or closer, it draws a little line directly to the point. So it's kind of like a nice way of just looking at it. It repels the word away or closer to the point. And then I think the scale continuous, this is the exact same. He's setting his breakpoints.
Yep, those are the same.
Chunking in the log, and then log scale on the y-axis. The labels are the same. And then here in the theming, this is just to kind of make things nice. He's basically getting rid of the background, making everything blank here. That's basically setting the stage for that cool like city map type of look that he's going to plop underneath this all. But he also does some stuff here with the legend position, actually. So just in terms of, he doesn't want the default legend position, which is going to be over into the right margin. He's going to move it to somewhere explicit. We'll see in a second here. It's going to be the upper left, and the legend background he sets to be blank, so that here Now we're starting to really look like what we had, sans the background, but this is starting to look pretty cool. You can see how geom repel. So for example, that high point in the middle, Second Avenue, Phase 1, New York, in the pink line there in the middle, it doesn't have any little repel point because it's not so busy up there. So the geom text repel says like, hey, this isn't a problem. Just throw that name right there. But then you can kind of see down below, like that one right there, line 4 in Milan. Geom text repel says like, geez, if I put that right there, it's going to be busy as heck. Let me just slide it over here and put up this little repel line that shows us what it's sticking to. So that's kind of cool.
Yeah, and it looks like, as with a lot of ggplots, it looks a little bit rougher on your screen than when you actually go to save it. As a PNG and whatnot. So
Correct.
Just keep that in mind when you're building your ggplot. Cool. So we've got like the basics set up here. The next thing is, because he knew that he wanted to make it look like a subway map, he wanted to add a map to the background. And rather than trying to call out a specific city or anything like that, he actually found a map generator. There's a link in his blog post. Definitely go check that out. There'll be a link in the description here, of course. And it randomly generated a cityscape or city map, which I think that's really cool. That's really fun. And so he saves it as a PNG. I ripped that off of his website so that I could use it too, for this example here. So it's going to use the read PNG function out of the PNG package to actually turn it into a raster that could be, I think, a raster that can be used for actually plotting, adding it to the background. So we're going to read that in, and once it's just like the next step in the visualization, same initial processing, the same start to the ggplot where he's defining his aesthetics X and Y, but because he wants it underneath, remember ggplot is a layered system. It builds on itself. And so because he wants to have this map be on the very bottom layer, he actually has to add that first. And so that's what this annotation custom is doing. He's adding, he's going to be adding the map there using the raster grob object. So it's saying, take this graphical object, grob, raster it, and now let's add it into the ggplot. This is the object, the map there. He's setting the width and height to be 1 NPC, which I think is a generic measurement tool in plotting, which is saying just make it 1. Fill it out.
Okay.
And then the position here, he basically wants it to stretch across the entire background.
Yeah. So there's 4, right? I think it's a X end, like a start and end on the X axis and a start and end on the Y axis.
Yes.
And he's saying go from negative infinity to infinity. So
yeah. So
everything you can.
Then same geom step, geom point, text repel. No changes to the rest of the plot. This is just adding that background in. So let's run that. And it's gonna take a little bit of time, because now it doesn't just have to figure out where to draw all those lines. It's got to figure out how to make the plot and the background show up too. So
there
it takes
is.
a little bit of time. So boom, there you go. Here, let's do an export. So let's just save it as an image, just so that we can actually look at it and look nicer. So we're going to do that. We're going to change the width and height. We probably want to make it actually fairly large so that it shows up nicely and we can capture all that detail. So we're going to set the width to be 1500 because it's definitely a wider than it is taller plot, and set it to be 1000 wide. I believe these are pixels, so we're going to save that. Now I'm going to open that up, the R plot here. Shablammy. There we go. And that is that is more or less what he created here.
Yeah.
I think it's an awesome viz. I'm definitely going to steal a couple of those techniques and tricks.
Super awesome.
The rest of the stuff that I work on.
one of the things with his theme at the bottom of his plot, where he did legend background equals
Element blank.
blank. That's really important because if you didn't do that, you would have a white backdrop underneath that legend, and so it would stick out like a sore thumb on this map. So he made it completely blank so that the legend actually sat over top, and he actually moved the legend onto the plot space so that it wasn't off into that white margin and kind of looking weird, which is pretty cool.
Yeah. So this is an awesome viz. Thank you so much, Martin, for letting us go through and explain how it worked.
And what happened to the text repel though?
Because the plot
Because
is
it's
so large.
now it's so wide. There's no need to repel.
But the nice thing is that it automatically kind of shifts them up and down around
Yeah.
the point, so they're not
Right.
exactly on the point, which is the other benefit. Is it doesn't just repel it from overlapping with other text. It slightly shifts it so it's not sitting on top of the actual point, and you don't manually have to define that.
It finds the genius R gods have figured out a way to find the optimal place for the text to go without us having to explicitly do it, which is nice.
Exactly. So this is an awesome viz.
That's cool.
Thank you so much for letting us go through that. But this inspired us. So we didn't initially realize this wasn't an actual plot or an actual map.
Yeah.
And so we went and we wanted to continue our efforts learning more and explaining Plotly. So we're like, oh, awesome, we can use this and we'll do something mapping with Plotly.
Until we realized this wasn't a map at all.
But we're still going to do a map.
Because
Because we think it's a cool thing to do.
Yeah.
So let's go over here. Let me restart my R session. And Pat, you can maybe explain.
Yeah. So when we were kind of like kicking around, texting back and forth, oh, well, what should we do this week? And we looked at Martin's and we said, it's a map. And I said, oh, what can we do for maps? And then I remembered Jose Fernandez is a guy that works for the Houston Astros, doing sports science analytics type stuff. And he does a lot of nice stuff in R. He's a great Twitter follow. If maybe one day we could interview him on the show. He does a lot of stuff in R. Nice Twitter follow. And he has a package that he wrote called Airball, which is all about travel in the NBA. So flights from your home stadium to the away stadiums, because we know, NBA travel is brutal. It's 82 games, and sometimes they're on the road for 2 weeks at a time. And so he has this package, and I had never used it up until this week. I felt like, oh, we're going to do a map, and this seems kind of cool. This seems like kind of cool, relevant sports data. So let's try out Airball. So that's what we did.
Yeah.
There's some notes there on installing. Just a side note, you do have to install NBA StatR. Yep, which is a great way to get NBA data if you're trying to play with NBA data. So you have to install that, and then you install Airball. In the code, we have how to do that from GitHub using DevTools. We've installed it, so we have obviously our Tidyverse, our Plotly, and our Airball package now all installed. And we run all that, and we use the NBA travel function, which is going to pull out the latitude and longitude of the stadiums that the team traveled to throughout the season. And in this case, we're selecting the Golden State Warriors in their championship 2015 season. And it's Golden State, so it's kind of a good travel a good travel team to look at, because they go all over the country.
Yeah.
So.
Mm-hmm. Exactly. And so we can load this in. So NBA travel comes from Airball. There's a couple functions in Airball, and they just give you a whole swath of information.
Yeah.
That we're only going to be scratching the surface on this. Because we were focused on specifically making a map.
Yeah, we were bent on making a map.
We're going to do a map, darn it.
We're doing a map.
So it's going and it's pulling a bunch of data from an external database. And so now we've got this games object here that it's a tibble that's got season. phase, month, week, date, team. So the team that we pulled, which is Golden State, because you also have the opportunity. You don't have to define a team. We could just say, give me all the travel schedule for the 2015 season.
Yes.
Or the 2015, 2016, 2017 season. And I mean, it obviously takes
which will it'll chug for a while if you did that.
Yeah. So that's why I limited it to only 2015 Golden State. So now I'm going to add an identifier for the game itself just by going, so into the game field here, go 1 to the number of rows games.
Just under the assumption that the games are ordered in in date order.
Yeah.
And obviously there's 103 because we have playoff games here. So.
And there were a few of those, I hear.
Yeah.
So then we're going to pull out, we were interested in plotting the travel specifically. Because this has obviously all the games. Some of the games are home. We wanted to pull out all the traveling. So we're going to pull out any cases where they didn't have to travel. So now we've got this new travel data set here. But the first thing that we wanted to plot was, where are all the stadiums? Where do they all exist across the nation here? So what we're going to do is we're going to take the games data set here, and we're going to filter to keep any time location is away. So that'll give us all the locations of the stadiums for non-Golden State teams. It was a grouped data table that we were handed off to by the NBA travel data set or function there. So I'm going to ungroup it, and then I'm going to select only the fields that I care about, which are the opponent, the latitude and longitude. And I'm going to rename opponent to stadium because I'm going to consider the opponent where they played the opponent to be their stadium. Yep. And then I'm going to call a distinct on it. And what distinct is going to do is going to remove any duplicated records. So then I only end up with one record per opponent, latitude and longitude, or stadium latitude and longitude. And so we should only have 29. And lo and behold, we have 29 rows.
29. There we go.
So the stadium for the Sacramento Kings, the latitude is 38.6 and longitude is negative 121. Blah 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 blah. Portland Trail Blazers, latitude 45, longitude 123. Blah 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 blah.
Yep.
So now we also want to get Golden State's stadium as well. And by the way, I wrote this code so that you can plop in your favorite team. You can run through all this as well, and it should work for you. So now we want the stadium home, so we're going to get the games filter to keep any time the location is home. Ungroup again. Select this. This time we're only going to be selecting latitude and longitude because we know that's the value that we want to keep. And call a distinct on that. So we should now only have one record, and then I'm going to add a column stadium and label it as home because that is the home team of Golden State Warriors or whatever team if you decide to run this and change it. So now we should have one record, so it's latitude, longitude, and home. So we're now going to bind them together to make a single data set and call it stadiums. So now we've got 30
latitude rows. And longitudes.
Yep.
Yeah.
All right. So this is going to be... So Plotly has a couple different mapping engines, essentially. Yeah. And this is the one that they suggest starting with when you don't want to do a bunch of custom stuff.
Yeah. So that you can Plotly has some integrated map stuff, which is easy to use and doesn't require a whole lot of heavy lifting. And then the second option is if you had some specific geospatial data that you wanted to work with and be more customized, that's the second option. So we kind of set this up into that sequence. This first one is leveraging the integrated Plotly map features. So we have this map data function, and I just call state, which means I want the continental United States. If I called USA, it would give me Hawaii and Alaska and places that the NBA doesn't travel to. So I just went with state in order to get the information of the United States. And then I'm going to plot that info as a map box. So I'm going to use the long and lat variables from that state map data. So if we were just to run those two bits of info, if we're to drag those across the, if we're to run those two bits of information,
Right.
we need our token.
Here, let me pop that over real quick.
Grab the.
That's supposed
So
to be
that is
secret.
one of the things that you will need is you'll have to go to a website and get a map box token. So the website basically just has all the information about latitude and longitude and map information for the
Here we go. So now we'll run that.
for the world. And there we go.
Oh, sorry, I ran all of it.
You ran all of it.
Alerts.
Oh, you spoiled it.
Okay.
No. If we ran it just by itself, we get a map, and there's obviously outlining the states. So it's the latitude and longitude.
Markers.
Yeah, exactly. Well, it's basically, if we were just to run it, right? It's by default plotting the little marker points that are outlining the state. And so if we look at that map data again, you'll see that it's like a massive data set of every longitude and latitude. Like Alabama is plotted there X number of times, right? Several hundred times, because it's outlining the entire state.
Is it? What's the column header?
Region. Yeah. So you can see how many points make up. So Texas, like a very big state, it makes is 1,088 points. Nevada, a bit smaller, 70 points to highlight that one, et cetera, et cetera. Yeah. So that's basically just a way for us to get our map. We want to make sure that we're highlighting the state. So that's what the plot map box does. Now we're going to throw in our add markers. So this is where we're actually going to put the stadiums onto the map. So we call our data, which is the stadium's data that Ellis just made up above. And then we do our X and Y are going to be the longitude and latitude to correspond to the map box. And those come from the columns in our data set. And we're going to do some coloring. So if it's the home stadium, we're going to choose orange, and the away stadium's blue. The orange and blue obviously is Golden State colors. We set the size to explicitly be 20. And then we're going to have a little bit of hover info, a little bit of a tooltip there that basically says if you roll your cursor over the stadium point, you'll get some information on the stadium. So here we are. And there's Trailblazers, Minnesota, Indiana, Cleveland, the great state of Ohio, Orlando, Miami, et cetera, et cetera. So that's a way to kind of get us off the ground in plotting points on a map.
Just a high level view.
High level view.
All right. So now we're going to go through and we're going to show the more custom version that you can do with Plotly here. So the first thing you need to do is kind of define what the map projection, the area that you're interested in looking at. So you define this in a list. You set the scope to be, in our case, we said it would be North America. The projection type, so there's lots of different map projections. So, the world is round. We're looking at a flat screen. So how do you view that? And there's obviously lots and lots and lots of opinions and thoughts on the best way to do that. I will not claim to be a person that actually knows anything about that. So
you're not a cartographer.
I am not, surprisingly. So I just used the value that Plotly had in their example, which was azimuthal equal area. I set show land to be true because I want to see land. I set the land color to be a specific gray and the country color to be a different gray. And we just now have a list of this information that we will eventually pass to our Plotly object to say, hey, this is how I want the map to show up as. And there's a bunch of custom stuff that you can do with that. You just have to kind of dig around, look at examples, look at the documentation. I wish the documentation was a little bit clearer sometimes, but what can you do? So now we're going to start our Plotly. First thing we do is we start the plot geo. We need to tell it the location mode, which is the US, and the coloring around it, which we want it to be red. Now we're going to add the markers. And so these are going to be the same markers that we had in the first example, where we're trying to put the stadium stadiums there. It's actually here. Let me. For some reason, I don't have this code there, so let me copy and paste this code. Down here, we decided we didn't want to do symbol anymore, so it's the same marker, adding a marker code as we had in the original example here. So let's quickly run that. Boom! There you go. There. Zoomed in.
Came out tiny. There we go.
Yeah. So this is more or less a similar situation that we had before. Make sure that I ran that. But now we're going to add some more information. First, we're going to add the layout. So this is how we want the visualization to show up. We're going to add the title, which is going to be the unique of the team. So we're going to get the team name and which season we pulled, which was the 2014-2015 season, and append the word season or words season travel to it. So it'll show up Golden State Warriors 2014-2015 season travel.
Mm-hmm.
We're going to set the geo to be that geo list that we just created, but we're not going to be showing the legend because we don't really care about showing the legend in this situation. And so now we've kind of defined how we want the plot to show up based on what we have here. Let's add the lines. Where did the team fly around to between during the season 2014-2015 season? So this is where we're going to actually add our travel data now. So we're going to take the object travel, the x-axis. So we're drawing now segments. So that's why we're using add segments to do that. So we then have to define a start and an end to that segment. And so the x start will be longitude. The x end will be d dot longitude. So that is the destination longitude. Same with the y latitude, y end, d latitude, destination latitude. We're going to set the alpha to be 0.3, so it's a little bit more transparent. So if there's overlap, we can see that. We're going to set the size to be identity of 1, so that way it will always show up as 1. And then we're going to try to add a little bit of context. Try. You'll see something in when we showed this plot that kind of confused us, and we kind of shrugged our shoulders and said, okay. Which is we're going to add information about where they flew to, was that a win or a loss, and how long that flight was. Just add a little bit of context around it. I mean, we're not going to really be able to glean too much information out of this, but, could be fun. You could probably come up with some interesting ways to deal with it. So this is now our new plot, where we've got the stadiums showing up here. This is their home stadium here in the Bay Area. This is them flying. So the hover. So what I thought was interesting is the stadium obviously shows up correctly, but the opponent that it's showing is incorrect. As well as I think the win-loss, because I don't think it takes 3.5 hours to fly from the Bay Area to Portland. In fact, I know it doesn't.
It shouldn't.
But I think they're all off by 1, because I wouldn't be surprised if that was this game. And then what it's showing now, and then what it's showing now is actually this game. So the labels are off. And we couldn't figure out how to fix that. I mean, you could probably do like an off by 1 in your table, and if you really cared, I was more interested in showing how to make this happen, and sharing it with y'all. So yeah, but there you go. So now you can kind of look around and go, oh well, it took. Come on, labels. There we go. Their opponent was the Detroit Pistons. They won, and the flight time was 55 minutes because they probably flew between 2 very close cities.
Yeah, those East Coast trips.
Yeah.
You're just bouncing around.
Charlotte Hornets.
Lot of options here. You could color the lines maybe by distance. The other thing is because basketball, this is one of the things that they talk about in the media a lot with like load management and the travel. You could probably write a mutate into the data frame that basically tells you the length of days away from home. So now you have like how long a road trip is, and maybe color by like, oh, this was a 6-game road trip, 5-game road trip, or whatever.
Group by road trip.
Group by road trip, and that, if you were maybe like working for an NBA club, that would be an interesting way to evaluate your travel. And you could obviously put, if you had other info, which an NBA team would be privy to, not so much in the public space, you could put info into your tooltip in a report that says maybe like number of starters sitting for load management or injuries on the road trip, or all kinds of information that could be really contextual and maybe tell a rich story about the way that your team traveled around the country, which might influence how you do things the next season or how you manage things going forward. So, pretty cool.
Making decisions.
Yeah, making decisions, exactly.
But yeah, so this was a lot of fun to put together for y'all. Play a little bit more with mapping, because I honestly wasn't sure if Plotly did maps. And clearly they do, and they clearly do a actually relatively good job. I think this is like the smoothest intro to plot or mapping that with an R package that I've had in a long time.
Yeah.
So thank you for that, Plotly. And I think with that we can call it. Thank you so much for joining us. As always, you can find, or my name is Ellis Hughes. You can find me on Twitter at Ellis_Hughes.
And I'm Patrick Warden. You can find me on Twitter at OSPPatrick. And you can find the screencast on Twitter at tidy_explained, or you can email us at tidy.explained@gmail.com, or you can comment on the YouTube video, which seems to be most people's preferred way. But either way, we will read the comments, emails, and tweets, and we will get back to you.
All right. Thank you so much, and keep on exploring your world.